Okay, so a lot of you have been a little bit worried. What happens if our numerator has a larger degree? That's the third case we haven't talked about. Truth of the matter is there is not a horizontal asymptote. There is a slant asymptote. In our case, we're going to call it a slant asymptote because we're only going to look at when the numerator is larger than the denominator by 1 degree. If it's larger in general, we would call them oblique asymptotes. But since they're larger only by 1 degree, and the ones we're going to look at today, we're going to call them slant asymptotes. I say the word slant asymptote. With your arm, show me what you visualize. You all are showing me a line with slope. Do you agree? Yes. Okay, let's think about this. Our numerator is larger by 1 degree. If our numerator is larger, what can we do with our fraction? Okay, like if we have 5 halves, I would say that we couldn't simplify 5 halves, but we could take 5 and divide it by 2, right? To get 2 with a remainder. Okay, we have an improper fraction essentially, which means we can perform division and get a quotient with potentially a remainder. Okay, so since our numerator is larger than the denominator by 1 degree, we are going to actually use division to get what our slant asymptote is. And that's really all we're going to work on today. I'm going to teach you how to find the slant asymptote. We are not going to graph them until Monday. Do you know that was coming? So to find them, we're going to use division. I put synthetic or long division because it all depends on what that denominator is. Okay? And then whatever we get for the quotient is going to be our asymptote. This is the one time where we don't care about the remainder. It could be 0, it could be 15, it could be x plus 5. I don't care what the remainder is, but it doesn't matter. Whatever the quotient and the quotient only is, that is our equation for the slant asymptote. Okay. Today I'm going to give you a worksheet where I only ask you to identify the asymptotes, and then on Monday I'll tell you how to put everything together on the graph. Okay. Let me grab those so I don't forget. Give them to you. All right. Ready? Okay. Just get it out of the way. Write this one down. Okay. My first piece of advice to you yesterday was to always do what? Factor first, just in case we can simplify. Okay? So I can see that I can factor out an x in the numerator, but then that's it. Right? Oh, yep. Can we simplify? No, we cannot. Okay? The next thing I asked you to do was identify the vertical asymptote. Okay, practice for your quiz here. Emily B, where is our vertical asymptote? Make sure you write it as a line, x equals -1. That's where the denominator is 0. Okay, now here comes the fun part. Okay, the next step I ask you to do is identify the horizontal asymptote. Okay, well, since the degree of the numerator is larger than the degree of the denominator, we say no, we don't have a horizontal, we have a slant asymptote. Okay, and in order to find that slant asymptote, we need to perform division. Okay, who votes we use long division? Who votes we use synthetic division? All right. We can use synthetic division because we have a divisor that's linear. But essentially, we're going to take that fraction and we're going to perform the division. We are going to take 1x squared minus 1x plus 0. And we are going to divide it by x plus 1. Okay. When I factored it, it's not very helpful in this case. Okay, I had to go to the unfactored version to get our dividend and divisor. But your numerator is your dividend, your denominator is your divisor. Okay, so what we're going to do, we're going to drop the 1, multiply by -1. Okay, add to get -2. I don't care what the remainder is. The remainder doesn't matter. What are we left with? We're left with x minus 2, right? So our slant asymptote is y equals x minus 2. We're done. All you have to do is perform the division. Questions? Not as bad as you thought? Okay. Okay, you guys are like moaning and groaning over here. What's the problem? You don't think we can?
You can take an X out.
Ah, Guy is suggesting not to panic because we can take an X out of our numerator and denominator, can't we? We can take an X out, x squared plus 4x plus 3 divided by x times x plus 2. Hey. Guy, this was your suggestion. Tell us what's happening because we canceled those out. There is a hole at x equals 0. So we would need to graph that when we would actually graph it. Our vertical asymptote. Okay. Andrew, where would our vertical asymptote be? Okay, x equals -2. Okay, I hear some discussion. Do we use synthetic division? Do we use long division? Which ones do we divide? Okay, I'll tell you what. Whether you do the division here or the division with the simplified one, it's going to be the same no matter what. Which one is less work? The simplified one. So let's go ahead and do the division with our simplified fraction. We are going to take x squared plus 4x plus 3 and divide it by x plus 2. Okay. Remember, the remainder does Not matter. I don't care about it. Don't find it. Okay. Left from our division is x plus 2. So our slant asymptote is y equals x plus 2. Emma. We can factor the numerator, and thank you for asking that. We can factor the numerator to x plus 3 times x plus 1. It's not going to cancel out with x plus 2, which is why I didn't push that. But if we factor the numerator, that would help you with your intercepts. Okay. Okay, so you're ready to listen to my instructions? Because this isn't written on your gold sheet, so listen. Your assignment is the pink sheet, only the front side, and only A, B, and C. Actually, yep, A, B, and C. 1, 2, 3, A, B, C. You can think of that song. Yes.
When you how would you find the intercept of problems? You just have it set equal to 0 or something?
Yeah. So the x-intercepts, you could set really just the numerator equal to 0. And for y-intercepts, you just plug 0 in for x, and you're left with whatever the constants are. Yep. All right. ABC 1, 2, 3. That's your homework.